Thank you, Dennis, very much. Thanks for inviting me. I've got quite a few slides, so I'm going to try to go through these fairly quickly. You have access to them for the details. But I'd like to really start by talking a little bit and picking up on some of the things Len started us off with this morning about what's changed since TSCA was adopted in 1976. Clearly, there's been a strong upward trend in just the sheer volume of chemicals being produced. One estimate here, about 25-fold increase since 1970 in dollar value of sales, roughly matching the increase in volume. While the number of chemicals has not necessarily increased by that amount, you can see here a projection for the next several decades showing if anything, an even more accelerating trend and just in terms of the sheer volume, outpacing population growth by a dramatic margin. The other thing that's changed is the diversity of use and the expansion of chemicals into and replacing natural materials and just the diversity of products and materials that are available on the market. That includes building materials as well as consumer products, with one estimate being that some 96% of all materials and products are made using or contain chemicals. Another thing that's changed, our understanding of how chemical exposures may occur has changed dramatically in the last several decades. The advent of biomonitoring during that period has shown that we all carry around hundreds of chemicals in our bodies, and every time we look for more, we find more. A lot of debate over what that means and what the combination of those chemicals in our bodies means. Our understanding of how chemicals move in the environment has evolved a lot in those several decades. And our ability to understand that chemicals that had been used in products that we thought maybe would just stay where they were, in fact, get out of those products and into us. And just two examples in recent years, our understanding that flame retardants, brominated flame retardants used in furniture foam actually end up in the dust in our homes, because every time you sit on an upholstered item, a little bit of dust poofs out, and that includes those chemicals, and then that dust is either ingested or inhaled. And that's a pretty clearly established now pathway for exposure to something that we didn't ever really think about, certainly not several decades ago. Coal tar-based sealants on parking lots. The U.S. Geological Survey has done some amazing work tracking PAHs in sediments and streams, and then looking back at the source of that being the sealants put on parking lots, principally, and has now extended that work to find that in apartment buildings adjacent to parking lots that are treated with these sealants, people are literally tracking this material into their homes, and it's ending up in higher levels of PAHs in the house dust in those homes. We also have a much better understanding today about the ability of chemical exposures to be disproportionate, that there are populations and subpopulations that suffer from higher exposures due to multiple sources, and that raises a lot of core environmental justice concerns that we are much more cognizant about today. There have been a lot of science drivers that have both changed the landscape of our understanding, but also driven more demand for changes in the underlying policies. We know a number of diseases are on the rise in the human population, despite an overall trend of reductions in many chronic diseases. Certain exceptions exist. Childhood cancers and leukemias, for example, increases in infertility and other reproductive problems, learning and developmental disabilities. We know from laboratory studies with animals, but also sometimes epidemiological data, that certain chemicals can be linked to those same kinds of effects. And we know that from biomonitoring and other sources of information that those chemicals are often found in us. Now, that is still a circumstantial case in many cases, but it's increasingly one that is showing connections between those exposures and diseases and disorders that are rising in the human population, certainly faster than genetics or something like that could explain. That's led to a growing recognition of a lot of other ways in which differential susceptibility to chemicals arises. Understanding that early life exposures can have a very significant effect even on a lifetime basis. That chemicals that mimic biologically active chemicals that are normally in our bodies, like hormones, can have an outsized effect, especially early in development, and the whole emergence of the endocrine disruption debate around that. New understandings of how epigenetics might be a mediator for chemical as well as other environmental exposures, and potentially a basis for explaining some of this variability in susceptibility, the ability of early life exposures to lead to later life outcomes in areas, in a lot of different disorders and diseases. That seems to be a pattern that's emerging. And even the potential for transgenerational effects to be carried through epigenetics, still a very controversial concept. Our ability to, and how we go about assessing these risks has changed dramatically since the Red Book in 1983. A lot of issues that are on the table now and part of that debate, how to better assess and take into account human variability that we are increasingly recognizing, not only in terms of inherent properties like genetic variability, but also a lot of other sources of variability across a diverse human population. What does that mean for the levels of uncertainty associated with identifying a level of concern for a chemical? The whole concept of how we start to address dose-response questions when we're dealing with cancer and non-cancer, and a call for a much more unified approach in the way we think about those issues as a part of the Science and Decisions Silver Book report that came out in 2009. And this whole question about whether when you start looking at a diverse population, does it still make sense to consider that there are thresholds below which there's no effect? There may be very well established a threshold in a laboratory setting, but when you put that across a diverse human population, does that assumption still stay warranted? Especially in light of cumulative effects and the fact that we are being exposed to multiple chemicals and other types of stressors. There's been a lot of advancement in technology for being able to begin to understand the landscape of potential toxic effects, and the emergence of the Tox 21 program in the federal government has been starting to try to apply these high throughput measures, both in vitro and in vivo, to look at toxicity pathways, and we'll be hearing more about some of that work later in this workshop. They have the enormous potential to do a lot of things that we've always struggled with in the toxicity testing that's been done. How to deal with the multiplicity of doses at which you might want to look at a chemical, assessing mixtures, different cell types and life stages and so on. They also have their challenges, and here are just a highlight of some of those challenges. How do we ever move from an in vitro set of assays to understanding the full implications in a whole organism? How do we map that full biological landscape that might be being affected by a chemical exposure, et cetera? Okay, so I'm going to shift now and talk a little bit about TSCA and why so many of us believe that we need a new law. And Wendy has touched on a few of these things in her presentation just now, so I'll go quickly. In the arena of existing chemicals, this large body of tens of thousands of chemicals that were grandfathered in, essentially that TSCA created a presumption that those chemicals were safe. And until and unless EPA found really compelling evidence of harm, those chemicals were basically deemed to be off limits. What that's created in part is an odd disincentive to create new information and increase our understanding of chemicals. And that's because the default here is that if you don't have information or that information is uncertain, you don't act and you wait for more information. Because there's a high hurdle to require testing, that information may not be forthcoming anytime soon. And Wendy's estimate of 5 years on average for a test rule is Exhibit A in that concern. The high level of requirement for proof of harm in order to actually take action to regulate chemicals, and the burden of proof being on EPA to do that, and a very marked difference in the way we regulate chemicals like pesticides and drugs that Frank at the beginning indicated are designed to be biologically active, and yet we now know a lot of chemicals that were never designed to be such actually are. Do we need a paradigm shift here? This is the sort of summary slide I use to talk about how little has happened under this law in the last 37 years now. I think most of these were already touched on by other speakers, so I won't dwell on it, but I love that picture. Now, new chemicals. I think it's gotten popular to argue that the new chemicals program is the success story under TSCA. I beg to differ. I think certainly more has been done there, in part because of the mandate to review existing new chemicals in contrast to existing ones. But let me just briefly touch on some of the concerns that need to be addressed. No data, no problem. Because EPA cannot impose a data requirement on new chemicals, the vast majority of chemicals that come into the agency have no health data. 85% is the estimate that's been out there. This is a very marked contrast to just about every other country in the world that has such a program. And it means that EPA has had to resort to what I think they've done an admirable job of trying to develop, prediction models and estimation approaches, structure activity, and so forth, which have their strengths but also have their limitations. For example, those models basically, by and large, do not exist for mammalian chronic toxicity endpoints, which is where a lot of the action is today in our understanding of how chemicals may be affecting our biology. The catch-22 around EPA's ability to require testing has already been alluded to. You need data that suggests risks or very high exposures before you can require testing. And so as a result, that's really a big evidentiary burden as well as the administrative burden on EPA. One bite at the apple. EPA kind of has to look at that chemical and with the exception of places where they actually do impose some requirements, they have to make assumptions about what that chemical might be used for, what volume of production, really out into the indefinite future, because this is really their one opportunity to look at it, unless they take the route that Wendy mentioned of also promulgating a significant new use rule, which they do in about 6% of the cases of new chemical reviews. The black box nature of the new chemical program, Wendy mentioned the use of these consent orders, but trying to find them is almost impossible. And when you do find one, 90% of the stuff in it is often blocked out, including things like how long a company has to deliver the data that's required in the consent order. So it's a real frustration for those of us outside looking in. And then finally, somebody alluded to this earlier, the burden is really on EPA to find affirmative evidence of harm in order to act to control a new chemical. Carbon nanotubes that have been coming into the agency are an example of this, where EPA is able to require testing now for inhalation toxicity of those because there's studies out there that suggest that that is a real concern with the inhalation of these materials, but they can't require any other testing because there's no evidence out there that suggests it. So these brand new materials coming into the market, and only where EPA already has evidence of harm can it actually require something. Okay, I've got a couple slides I'm not going to have time to get through here, but one of them focuses on the dearth of information about use and exposure. And Lynn already talked a little bit about the limitations of what information is reported. Part of that is because manufacturers are the ones that are tasked with reporting that information. And especially in the use area, that information is often very limited, even in manufacturers' hands. So for example, in the 2002 data that Wendy described, about 3,600 chemicals were to report information on consumer and commercial use. 74% of those, the manufacturers indicated that one of the basic elements that should have been reported was not known or reasonably ascertainable. Now, that's not a fault of the manufacturers necessarily, but it's a fault of the system in providing a full picture of the use of chemicals. I'm going to have to skip that one. I do want to just briefly mention toxicity or hazard data and the still major limitations. EPA has done some really nice analysis in recent years looking at some of the most high volume and most in-use chemicals and found that many of those have major limitations still, especially in the chronic mammalian toxicity endpoints. This is an example of those 9,900 chemicals for which EPA looked for data and the extent to which data on some basic endpoints is available. So I will end with this slide. I think what many of us are beginning to look for is a variant really on what our speaker who spoke about REACH talked about, and it's a shift in not just the burden of proof necessarily, but the paradigm where we really need to, in my view, be moving to a system that requires an affirmative evidence of safety as a condition for chemicals entering the market or staying on the market. And that's what TSCA reform, the debate around that is all about. And I will end there. Thank you very much.
Thank you, Richard. So last up, we'll have the perspective from an industry point of view. Mr. Michael Walls is Vice President of Regulatory and Technical Affairs of the American Chemistry Council. He's been with the ACC for 22 years and has experience in a wide range of U.S. domestic chemical regulatory issues, including TSCA, the Emergency Planning and Community Right to Know Act, and the Resource Conservation and Recovery Act. His experience also includes work on international chemical regulatory issues, including the European Commission's REACH program. Mike has represented the industry in several international chemical negotiations and in support of U.S. ratification and implementation of these agreements. So welcome, Mike.